Namaskar bachcho. Once again welcome back to the virtual class. Hope you all doing well, and this virtual class is giving you much satisfaction in learning the concepts. In the previous sections, in the previous episodes, we have been learning many concepts in the chapter atoms and molecules. We have seen the law of chemical combination, the law of constant proportion and conservation of mass, and moving forward we have seen many other concepts, Dalton's atomic theory, what is ions and how valency is found out. Hope you understood all those concepts. Keeping in view you understood all the concepts clearly, so we move further to understand the remaining part of the concepts from this chapter, atoms and molecules. Children, in today's class we will be seeing gram atomic mass, gram molecular mass, what is mole concept, and at the end we will see some of the numerical problems which are very often asked in your examinations. So we start the session. Firstly, what is the gram atomic mass? In the previous section we have studied about atomic mass, right? Atomic mass we found out using relative atomic mass. We have taken 1/12 the mass of carbon atom, carbon 12 atom, as a reference to find the relative atomic mass of various other elements. Here 1/12 the mass of atom which we have taken earlier is considered to be 1 AMU. Later on it is simplified as U. So the unit of atomic mass will be U. It is represented by the letter U. Here U is unified mass. So whenever you find atomic mass for an element or a compound, the unit must be written. The unit must be U. U is unified mass. Similarly, we have found a molecular mass, how these atomic masses, relative atomic masses are used to find the relative molecular mass of different compounds. Children, in today's class we will learn about gram atomic mass. So is there any relationship between the atomic mass and the gram atomic mass? There is a relationship between atomic mass and gram atomic mass. Now we see about gram atomic mass. Children, gram atomic mass is the amount of substance whose numerical value in grams is equal to its atomic mass. So in the earlier section we have found out the atomic mass of various elements. Hydrogen has the atomic mass 1U, carbon has the atomic mass 12U, nitrogen has atomic mass 14U, as you can see here. Oxygen has the atomic mass of 16U. What will be the gram atomic mass of hydrogen? Just now we have seen that gram atomic mass is the amount of substance whose numerical value in gram is exactly equal to its atomic mass. So the gram atomic mass of a hydrogen atom will be 1 gram. Similarly, the gram atomic mass of nitrogen will be 14 gram. The gram atomic mass of oxygen will be 16 gram. This way we can find the gram atomic mass of various elements. How do we find? If you know the atomic mass of a particular element, from that you can easily find out the gram atomic mass. Whatever the atomic mass of that element, if it is expressed in gram, that will give you the gram atomic mass of that particular element. Now we see about gram molecular mass. What is gram molecular mass? The same way how we defined the gram atomic mass, here gram molecular mass is the amount of substance whose numerical value in grams is exactly equal to its molecular mass. In the earlier section we have found that the molecular mass of a hydrogen molecule is 2U. So we know that each hydrogen molecule has 2 atoms of hydrogen, and each atom has the atomic mass of 1U. So 2 atoms, 2 into 1U will give you 2U. So the molecular mass of hydrogen molecule will be 2U. Similarly, the molecular mass of oxygen will be 32U. As we can see here, oxygen molecule has 2 atoms and the atomic mass of each oxygen atom is 16U. So 2 into 16 is equal to 32U. So the molecular mass of oxygen molecule is 32U. So what will be the gram molecular mass of hydrogen, oxygen or some other diatomic molecules? The gram molecular mass of hydrogen molecule will be the molecular mass just expressed in grams. That means the gram molecular mass of hydrogen will be 2 gram. Similarly, the gram molecular mass of oxygen will be 32 G, that is 32 gram. Similarly, you can find gram molecular mass of various other elements. Now we will see some of the examples of molecules of compounds. In the earlier section, we have seen carbon dioxide is a molecule and it has the molecular mass of 44U. So the gram molecular mass of carbon dioxide will be 44 grams. And similarly, water, we have found out that the molecular mass of water is found to be 18U and the gram molecular mass of water will be 18 gram. So this way we can easily find the gram molecular mass of molecules of elements as well as molecules of compounds. Hope you understood how the gram atomic mass and gram molecular mass is found out by knowing the atomic mass or molecular mass of the elements combined. So I believe you understood how gram atomic mass and gram molecular mass is found out by knowing the atomic mass and molecular mass of different compounds or elements. Now we see about one of the important concept in atoms and molecules, that is mole concept. Before going to learn about mole concept, we should know some of the difficulties faced in our day-to-day activities. Dear children, as you know that banks have large number of coins and counting all the coins is not an easy job. What the bankers used to do is they just weigh the coin instead of counting each and every coin individually, as counting all the coin is not an easy process. And the bankers know the weight of each and every coin. For example, 1 rupee coin have some fixed mass, 2 rupees coin will have some fixed mass, similarly 5 rupee coin, 10 rupees coin. So all the coins have fixed mass. By knowing the mass of each coin, what they do, they collect all the coins of one particular denomination and they weigh. From the total weight, they can easily find how many numbers of coins are present in that particular mass. Suppose if they weigh 5 kg of a particular coin, from the mass of 5 kg, they can easily find the total number of coins present in them. So this way, bankers reduce the workload or the difficulty in counting the individual coins are eliminated by using a simple technique. By weighing the coins together and knowing the mass of each individual coin, they are able to know the total amount present in that particular mass. And one more example, you might have seen the fruit sellers and other vegetables in the market. They used to make certain fruits in a group and they sell, and each group will have same number of fruits. For example, they arrange 12 in numbers, 12 fruits in one group. So this way various groups will be formed, so that whenever a purchaser comes, then the fruit seller or the vegetable seller can easily shift or sell the fruits easily. Various other examples in our day-to-day life, they use certain numbers arranged in a pattern and accordingly they used to sell. For example, when any object is counted up to 12, we call it as dozen. So any articles which are 12 in numbers, we call it as 1 dozen. So here 1 dozen is equal to 12 in numbers. Similarly, when anything is counted up to 144, so anything is present in 144 in number, we call it as gross. By arranging articles to a certain numbers and give a name to a group will make the calculation process easy. So in order to make the calculation process or counting process easier, materials are grouped in certain numbers and we give certain name to these groups. In the earlier section we have already studied that atom is very small and we cannot see with our naked eye or with the help of magnifying glass. If a piece of iron is taken, if you count the number of iron atoms, it will be millions and millions. And doing calculation with these million number of particles, it is very tough, difficult job. So the scientists were searching about a particular number through which we can make the calculation process easy. Dear children, in the previous section we have seen that the bankers identify total number of coins present in a group by knowing its mass. So the banker finds the total number of coins present in a group by knowing its mass. So here the number of coins present in a group is linked to mass of the coins. Similarly, the scientists count the number of atoms or molecules by its mass. So scientists were searching about a method by which the total number of atoms could be found out with reference to its mass. It has been found by experiment that when an element is weighed to its atomic mass in gram, then it contains 6.022 into 10 to the power 23 number of particles. This means the gram atomic mass of an element is exactly equal to 6.022 into 10 to the power 23 number of particles, and this particular fixed number is called mole. So here 1 mole of any element contain exactly 6.022 into 10 to the power 23 number of particles. So instead of using this large value, we can use 1 mole. So here 1 mole represents 6.022 into 10 to the power 23 number of atoms. If we take 1 mole of an atom, then it is equal to 6.022 into 10 to the power 23 number of atoms. If we take 1 mole of a molecule, then it will contain exactly 6.022 into 10 to the power 23 number of molecules. So this value is a constant, and this constant was given by Amedeo Avogadro, an Italian chemist. To honor his name, this constant is named as Avogadro constant, or we call it as Avogadro number. So we can say that 1 mole of any atom is equal to 6.022 into 10 to the power 23 number of atoms, or Avogadro number of atoms. By experiment it was found that 1 mole of a substance is exactly equal to its gram atomic mass or gram molecular mass. We know that the gram atomic mass of hydrogen is 1 gram. So here the total number of atoms present in 1 gram of hydrogen will be 6.022 into 10 to the power 23 number of hydrogen atoms. Suppose if we weigh 12 gram of carbon, what will be the total number of carbon atoms present in it? We know that the gram atomic mass of carbon is 12, and we just now studied that 1 mole is equal to the Avogadro number of particles, or which is equal to its gram atomic mass. So the gram atomic mass of carbon is 12. So the total number of particles present in 12 gram of carbon will be equal to the Avogadro number of particles, that is 6.022 into 10 to the power 23 number of carbon atoms will be there in 12 gram of carbon. Similarly, if 44 gram of carbon dioxide is taken, then what will be the number of carbon dioxide molecules? Again, we know that the gram molecular mass of carbon dioxide is 44 gram, and just before we have seen that the gram molecular mass is equal to 1 mole, and we know that 1 mole is equal to 6.022 into 10 to the power 23 number of molecules will be there. So if we weigh 44 gram of carbon dioxide molecules, then total number of molecules present in carbon dioxide is equal to Avogadro number of particles. Hope you understood what is mole concept, and whenever you think of a mole, then it should be related to a constant value, that is 6.022 into 10 to the power 23 numbers. And this number is called Avogadro number, represented by N0, as you can see here. Just now we have seen what is a mole concept. A mole is a group of 6.022 into 10 to the power 23 number of particles. This is a constant value, and this constant is known as Avogadro number. The same will be used in solving numerical problems, which we will see in the next section. Now we will see what is a molar mass. Molar mass is the mass of 1 mole of any substance. Suppose 1 mole of oxygen molecule is taken, the mass of 1 mole of oxygen molecule will give you the molar mass. So molar mass is equal to the mass of 1 mole of any substance. So molar mass also we will use in the next section for solving numerical problems. Now we will see how numerical problems could be solved by knowing the gram atomic mass, molar mass and mole concept. So these three are very much interrelated. How it is interrelated and how these quantities are found out, about that we will see now. Look at the screen where you will find a question. Children, look at the question. Convert 22 gram of carbon dioxide into moles. Here atomic masses of carbon is given as 12U and oxygen is 16U. We know that carbon dioxide is a molecule, so CO2 is a molecule, and gram molecular mass of a compound is equal to 1 mole. So here we can write gram molecular mass of carbon dioxide is equal to 1 mole, right? Firstly, we have to find the gram molecular mass of carbon dioxide. We know that the gram molecular mass is the molecular mass expressed in gram, right? So firstly we need to find the molecular mass, and from the molecular mass we can find gram molecular mass. Here the atomic mass of the constituent elements of carbon dioxide is given. We know that 1 atom of carbon and 2 atoms of oxygen are there. So mass of carbon is 12U plus 2 oxygen atoms are there. So 2 into each oxygen atom 16U. So 2 into 16U. Finally solving this we will get 44U. So 44U is the molecular mass of carbon dioxide. If the same is expressed in grams, 44G will be the gram molecular mass. We have found out that gram molecular mass of carbon dioxide is equal to 44 gram. In the previous section we have seen that gram molecular mass of any substance is equal to 1 mole. So 44 gram of carbon dioxide is equal to 1 mole. Now see the question. 22 gram of carbon dioxide into moles we have to convert. So 44 gram of carbon dioxide is equal to 1 mole. Here 1 gram of carbon dioxide will become 1 by 44 mole. Got it? So here 22 gram we need to find out, right? So 22 gram of carbon dioxide is equal to 22 into 1 by 44 mole. So 122, 22, 222. So finally we will get 22 gram of carbon dioxide. So the value of 1 by 2 will be 0.5 mole. So this way we can find the moles if the mass of any substance is given. Hope you understood the numerical problem. Now we will see another numerical problem. Now look at the next question. What is the mass of 0.5 mole of water? How can we do this? We know that 1 mole of water, 1 mole of H2O is equal to gram molecular mass of water. Since atomic masses are given, we can find the molecular mass of water. Molecular mass of water will be 18U and the gram molecular mass of water will become 18G. We know that the molecular mass expressed in gram is gram molecular mass. So this way we can convert molecular mass into gram molecular mass. So next step will be 1 mole of water is equal to 18 gram of water. Look at the question. Since 1 mole of water is equal to 18 gram of water, then 0.5 mole of water we need to find. So here 0.5 mole of water is equal to 0.5 into 18 gram of water. So by multiplying this, solving this, we will get half of 18 is 9 gram of H2O will be our required answer. This way we can convert mole into mass. Hope you understood how the numerical problem was solved. Now we will see another numerical problem. Now look at the next question. What is the number of water molecules contained in a drop of water weighing 0.06 gram? How will we solve? We know that 1 mole of water is equal to 6.022 into 10 to the power 23 number of particles, right? And also we know that 1 mole of water is equal to its gram atomic mass. So here gram molecular mass of H2O. Previously we have found out that the gram molecular mass of water is 18 gram. So we can write like this: 1 mole of water is equal to 18 gram of water. In other words, we can write 18 gram of water is equal to 1 mole. And again we know that 1 mole of any substance is equal to the Avogadro number of particles, that is 6.022 into 10 to the power 23 number of water molecules. So 18 gram of water is equal to 1 mole. So here we can write that 18 gram of water will contain 6.022 into 10 to the power 23 number of water molecules, right? So if 18 gram of water molecules contain these many particles, then what will be the number of water molecules if the mass of water molecule is 0.06 gram? This is what asked in the question. So 0.06 gram of water will have 0.06 into 6.022 into 10 to the power 23 divided by 18 number of water molecule. When we solve this, we will get 2.007 into 10 to the power 21 number of water molecules. So a drop of water weighing 0.06 gram will have 2.007 into 10 to the power 21 number of water molecules. Hope you understood this numerical problem also. Now we will see another numerical problem. Look at the question. Calculate the number of aluminum ions present in 0.051 gram of aluminum oxide, and atomic masses of aluminum atom is given as 27U and oxygen atom we know that 16U. Before going to solve this numerical problem, here in the question it is asked to find the number of aluminum ions, that is Al3 plus, this is the ion. So don't get confused between aluminum atom and aluminum ion. Mass of aluminum ion and aluminum atom are the same. To solve this question, firstly we need to find the mass of aluminum ions present in 0.051 gram of aluminum oxide. How will we do? Let us see how it is done. We know that 1 mole of aluminum oxide, that is Al2O3, is equal to gram molecular mass of Al2O3, aluminum oxide, and we know that gram molecular mass is the molecular mass expressed in grams. So firstly we have to find the molecular mass of aluminum oxide, for which the mass of constituent elements are given. So here Al2O3, 2 atoms of aluminum, which is expressed as 2 into 27U, then 3 atoms of oxygen are there. So 3 into 16U, that is the mass of each oxygen atom. So by solving this we will get 2 into 27, that is 54, plus 3 into 16 is 48. So upon solving this we will get 102U. So when the molecular mass is expressed in gram, we call it as gram molecular mass. So here 102 G we have to write. So 1 mole of Al2O3 will have 102 gram of aluminum oxide, or in other words we can say that 102 gram of aluminum oxide is equal to 1 mole of aluminum oxide. Now from the formula it is clear that each molecule of aluminum oxide has 2 atoms of aluminum. So here 1 mole of aluminum oxide contains 2 moles of aluminum atom. So mass of aluminum in 1 mole of Al2O3 is equal to 2 atoms are there. So 2 into 27, which is equal to 54 gram. So 54 gram of aluminum will be there in 1 mole of Al2O3. Now proceeding further, above we have found out that the mass of 1 mole of Al2O3 is found to be 102 gram, which is the mass of 1 mole of Al2O3, which contains 54 gram of Al, right. So in 102 gram of aluminum oxide, 54 gram of aluminum atoms are present. If 102 gram of aluminum oxide has 54 gram of aluminum, then what will be the mass of aluminum ions present in 0.051 gram of aluminum oxide? So that can be found out as 0.051 gram is equal to 54 into 0.051 divided by 102 gram. By solving this we will get here 2, by cancelling this we will get 27, here 0.001, right. So by solving this finally we will get 0.051 gram of Al2O3 will have 0.027 gram of aluminum atom. We know that 27 gram of aluminum is equal to 1 mole. In 1 mole 6.022 into 10 to the power 23 number of particles will be there. So number of aluminum. So in 27 gram of aluminum we will have 6.022 into 10 to the power 23 number of aluminum. So here 0.027 gram of aluminum will have 6.022 into 10 to the power 23 into 0.027 divided by 27. So here 27 gets cancelled. Here we will get 6.022 into 10 to the power 23 into 0.001. So which can also be written as 6.022 into 10 to the power 23 into 10 to the power minus 3. So by solving this, we will get 6.022 into 10 to the power 20 number of aluminum ions will be there in 0.027 gram of aluminum. So this will be our required answer. This way the numerical problem can be solved. Hope you understood this numerical problem. Now we will see how numerical problems are solved by using mole concept. Here we have got two formulas. By using these formulas we can easily find the different quantities. There are two ways by which mole of a substance can be found out. The first one is, if you know the number of particles, then the first equation we can use, that is number of moles is equal to given number of particles divided by Avogadro number of particles. Here Avogadro number of particles is equal to 6.022 into 10 to the power 23. We know that this is the constant and we call it as Avogadro number. And the second way how number of moles could be found out, if mass of a substance is given, from that also we can easily find the number of moles. How it is done? Here number of moles is equal to the given mass divided by molar mass. So by using these two formulas we can easily find number of moles, given mass, molar mass, number of particles. So all these quantities can be found out by using these two formula. Children, based on today's learning, I would like to give some easy home assignments which you can practice at home. So here is your home assignment. So that's all in today's class, and we have completed atoms and molecules, and in the next episode we will be seeing another new chapter. Till then, take good care of yourself. Bye.